Roy?
I will stay my homework if I can find it.
Okay,
Can I go check it out?
no, you can do it later. Any other questions?
You got, the answer for 14.
14 is the law of cosines, 15.9. Again, for the video, I did have the video running, 8 is 36.9, for x, y is 53.1, 10 is x equals 5.1, y is 126.5, 12 is law of cosines, 7.4, and 14 is law of cosines, 15.9.
How did you get 126.5 for y number 10? Because I get 126.017.
We're looking for angle y, correct?
Yes, sir.
Alright, did you find angle A, or side A?
Yes, sir.
Alright, what did you find side A to be?
5.1.
Alright, and so for find angle y, we would have 9 squared equals 27 squared plus 5.1 squared minus 2 times 27 times 5.1 cosine y. Is
Where'd
that
you
correct?
get the 27 squared from?
I don't know, I was looking at angle 27. It should be 9, 5, and 5.1, right? So we have 9 squared minus 5 squared minus 5.1 squared, divide by -2, divide by 5, divide by 5.1.
Is it in your UTT notebook? In your UTT notebook, because we were doing that together.
Alright, so that's what we should have.
So what number is that? 10?
This is number 10.
Can I go grab that book really quick?
I get 126.0.
Yeah, that's what I got.
Okay. Andrew's book wrong. Maybe.
For number 10.
That's what
Oh,
we're doing.
yeah, that's what you're talking about.
Yeah.
I have to wait.
Were you going to ask like a different question or the same question?
No, well, I did love signs after I found the angle.
And you get 126.5 that way?
No, I get 53.24.
No.
And I just did it again. Because I have it set at sine of 27.
Yes,
over
that's
five.
probably what do it with by law of signs. Because technically there's some ways when you do a law of signs, you can get 2 different answers. But seeing they show us an obtuse angle, then it should be an obtuse angle that you get. If you do a law of signs, sometimes you get an acute angle. You won't get the obtuse angle.
Okay.
Remember when we talked about in pre-calculus, the 2 different situations for law of signs, depending on,
Can we go over it again?
Yeah.
Good answer.
but yeah, if you use the law of signs, depending on what you have, the side angle, there's 2 different triangles you could have. One could be obtuse, one could be acute. Yes,
So you don't know why this difference is 25?
I do not. Unless it's the rounding off at 5.1. Could be. Any other questions? All right, pass those forward. Let's review what we were talking about yesterday. Talking about vectors. Vector is a directed line segment. we have two forms we could write the vector in. We could write the vector and vector form that has a magnitude and degrees. Or we can write the vector and coordinate form, which has a x and y coordinate that represents the coordinate at the end of the vector. And we learned yesterday how to convert from one to the other. Here's our vector form. R, which is my magnitude, at theta degrees. And here is my coordinate form. X and Y. To get from here to here, how do I find my X value? R cosine theta. How do I find my Y value? Alright, to get from here to here, how do I get my R?
Square root of x squared minus plus y squared.
What's that?
X squared plus y squared.
All right. And how do I find my theta?
Tangent, arctangent,
Alright, when you do theta equals arctangent y over x, it gives you an angle in the first quadrant, or it gives you an angle in the fourth quadrant. But if it's supposed to be in the second quadrant, how do I know if the angle is in the second quadrant?
It's going to have a negative x and a positive y.
Alright, so I have negative, positive, and how do I get that angle from the angle that I get on my calculator?
Add 180.
Add 180. How do I know if it's in the third quadrant? Excuse me?
both are negative.
Both are negative. And how do I get that angle in the third quadrant? Add 180. How do I know if it's in the fourth quadrant? Positive, negative. How do I get that angle in the fourth quadrant? Add 360.
So what are you adding those numbers to?
To the angle that you get from your calculator. When you take the arctangent of y over x, it will give you an angle. It will either give you a positive angle or a negative angle. But I always want positive angles, and I always want it in the quadrant that it's supposed to be in. So. Alright, so let's take a look at one. I had the vector negative 3, 4. I want to put it back in vector form, magnitude, degrees. How do I find my R, my magnitude? Square root of negative 3 squared plus 4 squared, which equals 5. How do I find my theta? Arctangent of 4 over negative 3. Which somebody has their calculator, do that for me, please.
.023.
Should be in degrees.
I am. Oh, I'm
Negative
sorry.
53.1.
Yeah.
Negative 53.1. What quadrant should I be in? Lauren?
You should be in the second.
What's that?
The second,
The second quadrant, so what do I have to do to this angle?
add 180.
Add 180. So therefore my angle is
120, so it's 5, 7. I mean 9.
126.9 degrees. So my vector is 5 units at 126.9 degrees. Here we have a vector form, 132 miles at 315 degrees. I want to put it in coordinate form. So I'm going to find my x.
Or sine, no, or
132 times cosine of 3.5.
How will I find my y?
132 times sine of 315.
So 132 times the cosine of 315 is?
91.3.
Everyone agree? Yes? No?
Maybe, no, it's 93.3.
What's that?
It's 93.3.
93.3?
yeah.
And 132 sine of 315.
Negative 93.3.
Which is correct. Going from vector form to coordinate form, going from coordinate form to vector form. Yes?
I want to know how kind of like which I put an angle for the 50/1. How can I know it's which part? I'll use the -3 and 4.
That's why I have these here. Yes. Yes. And again, my R is also called what? What's the word that we use for R? The resultant. Resultant. Any questions on that?
Will we have to graph any,
Yes?
like in homework,
Yes?
you can graph them?
Mm-hmm.
Okay.
Getting ready to do that, yes. Any other questions on what we've done so far? When we have our coordinate plane, and we're dealing with direction, I have north, east, south, and west. My vector is always starting at the origin. And I can draw my vector according to the directions they ask. Okay, for instance, they asked me to go 30 degrees east of south. That means I'm starting at south and I'm going 30 degrees toward the east. There's my vector. If I ask me to go 25 degrees west of north, that's telling me I'm going from north and I'm going 25 degrees west of that. They could ask me to go 55 degrees north of east. I mean, we're gonna start at east, and we're gonna go 55 degrees north of east. So again, the directions will tell you exactly how to go. North of west. Starting at west, you're going north of that. East of south. You start at south, you're going east of that. And so on. They will tell you. They could just say, "15 degrees southwest." 15 degrees southwest. Should be here, west of south. West of south. Yes, sir.
Do they ever have like 30 degrees north of south?
No. It would always be a horizontal with a vertical. Horizontal with a vertical. Yes, sir.
So how do you tell which side to put the degree measurement on? Is it just like angle of depression or elevation?
It always should be from the axis that you went from. So here we went west of north, so we started at north and went west, so it's between north and west. Yeah, because you went that way. Okay? All right? Resultants. I don't know why I put a parenthesis there. The addition of two vectors. Resultants are the addition of two vectors. Say for instance, if I had these two vectors, 5 at 30 degrees plus 10 at 60 degrees. So that tells me I'm going 5 units at 30 degrees. After that 5 units, then I change directions. And now I'm going 10 units at 60 degrees. So if I look at these vectors in vector form, they make a right triangle. Well, my resultant is the addition of the two vectors. All right, what is my vector? My addition would be this vector here. Well, if I notice that green vector, if I put it in my coordinate form, I see the green is the same as the sum of the two red. So the easiest way to add two vectors is to change to coordinate form, add the coordinates, and change back to vectors. So we're going to do that. 5 at 30. How do I find my x? 5 at 30. How do I find my x? 5 cosine of 30. How do I find my y? 5 sine 30. 60. How do I find my x? Which is? How do I find my y? Which is? 8.7. So what will I do with those? Well, I'm going to take those and add them. 4.3 plus 5 is 2.5 plus 8.7 is what does that tell me? That tells me that this green side here is 11.2. This green side here is 9.3. So those are my x and y coordinates. That tells me the coordinate at the end there. Well, let's say I don't want it in coordinate form. I want to put it back into vector form. Well, how do I find my r?
Pythagorean theorem.
All right, which is the square root of 9.3 squared plus 11.2 squared. Which is
14.6.
How do I find my theta?
R coordinate of 11.2 over 9.
Which is
50.3.
50.3? All right, positive, positive. I know in the first quadrant, I don't have to do anything to my angle. So 5 at 30 plus 10 at 60 equals 14.6 at 50.3. That is my resultant. That is the addition of two vectors. What are we going to do? We're going to change each vector to my coordinate form. What we did here. This vector to coordinate form. This vector to coordinate form. Then we're going to take both those vectors, add my x's together, add my y's together, which we did here. 4.3 and 5, 9.3. 2.5 to 8.7, 11.2. That is my resultant in coordinate form. Then I'm going to take that coordinate form and put it back into vector form, which I did here. And that gives me my resultant. Vector form, coordinate form. Add the coordinates, coordinate form. Take the coordinate form, put it back to vector form. Went 14.6 at 50.3. That's when they're asking you to add two vectors. And they're asking you to add two vectors, which is what you do there. All right, let's look at another example. Take a look at -5, -3. I want to put it back into vector form. If I draw this, -5, -3 is here. All right? How do I find my magnitude?
Square root of 3 negative 3 squared plus 9
I got more than just Caleb in this class, come on. Square root of 9 plus 25, which is square root of 34, which is?
Oh,
5.8.
4 square root of 2.
Oh wait, that was up with 34 in. Three.
9 squared plus 5 squared, which is 34, the square root of 34.
Oh, the square root,
15.
you did say 34?
5.8.
Yeah, what Isaac said.
5.8. How do I find my angle?
Oh, that's no different.
Which is?
30 it's 31.0.
All right, 31.0, which is going to be giving you this angle, which we learned by geometry that these are vertical angles. So this is 31 degrees as well. So we learned it was in the third quadrant. So how do we find the angle in the third quadrant? Add 180 degrees. So 180 to 31 is
211.0.
211 degrees. But what if I don't want it in that form? What if I want it in directional form? What if I want it north of west or east of south or whatever? All right? So I could say that this is 31 degrees. And what directions would I do? South of west. Is how I would write that. So I could write it two different ways. I could say that this is 5.8 at 211 degrees, or I can say that's 5.8 at 31 degrees south of west. So I could write it either way. Okay? Alright, so this is what I want you to do tonight, this weekend for homework. I want you to write on page 529. Numbers 10 through, or rather 11 through 21 odd. '23 through 29 odd. I believe I said that right, 23, yes. And then 41 and 43. So 529, 11 through 21 odd, 23 through 29 odd, and 41 through 43. All right, everyone, have a good weekend.